Hi, everyone, and welcome. Thanks for participating in this talk pretty late in the evening. Hopefully, um, you still have a little bit of energy left to digest this. We'll get started shortly on some examples and considerations for your first machine learning model in production. I'll start a little bit by introducing myself. So I'm currently a principal data scientist at Altair Engineering. I manage a team of data scientists, and we work on a variety of different projects, both internal and external with clients. And we also actually take part in developing our own product for machine learning. Before I was at Altair, I worked as the lead product manager for machine learning at Points International, where I actually built our first system for getting machine learning models into production for real-time scoring. And that's what I'll be talking about as one of the examples today. Before that, I was the lead data scientist for marketing, also at Points, where I spent a lot of time building machine learning models. So let's get started. So I really love this quote from John Doerr on execution is everything. So it's really easy to create machine learning models, but it's really hard to actually put them to good use and make business decisions based on these machine learning models. And what I want to focus on today is taking it from the very beginning on how you think about creating machine learning models and what are some of the considerations that you need to think about when you want to take these models and put them into production. So the agenda for today will start with how you assess some of the business needs for your machine learning models, setting up those KPIs and starting to prototype the models, how you deploy those models, how you build pipelines to suit business needs, and then closing that feedback loop where we go back all the way to the KPIs and how we monitor those KPIs to assess our models. So what I'll go through today are the first three phases here on how we start with building a machine learning model, whether it's the right time to do that, how we build and deploy our first pipeline, and this last phase we'll capture is feature engineering. How do we launch and iterate over adding new features to your model? And how do you manage that kind of pipeline, as well as the different teams that are part of that pipeline? I won't go over the third phase during this talk, which is refinement of the models. So let's start with the first part of having a machine learning in production is figuring out if it's the right time to build a machine learning model for your system. So first step is to make sure that we map out our use cases. So depending on what industry you're working in, there are a variety of different use cases, whether you're looking at giving the right kind of offer on your e-commerce website, whether you're trying to upsell or cross-sell offers, whether you're approving credit, or you're doing predictive maintenance. The first step is to figure out what it is that you're trying to do. Do you have the right kind of data for it? And can you start actually getting some business value from putting models in production? The next step is to figure out what are the KPIs that actually affect your business outcomes. So regardless of what you're looking to do, whatever industry you're in, what are the KPIs that affect the bottom line for you, and how can you track these? So these could be, for example, either trying to convert people, buy a new product, and increase customers' basket sizes, whether you're trying to save money by detecting and preventing fraud or reducing risk, or whether you're optimizing your current business process. So figuring out these KPIs at the very beginning is crucial because you're going to have to be able to track these KPIs once your model is deployed and running in production. Now, let's go through an example on how to think about integrating your KPIs with model objectives. So let's say you're working in fraud and you want to build a model to identify potential fraudulent transactions. But it's not enough to try to just find potential fraudulent transactions. You want to especially stop large amounts of dollars from growing through your system if it's fraudulent. You might also have a KPI around wanting to reduce false alerts. So if you have agents sitting by that have to check all of the flagged transactions, you probably don't want to flag everything. So you have to find some sort of balance between figuring out, what it is that is the most important KPI for your business. So let's take this example with fraud. Let's say your first model that you build, you look at the accuracy of this model just as one of the metrics, and you find that the first model has an accuracy of 76%, and you find that the second model has an accuracy of 94%. And you probably know where this is going, that this is not enough. You want to not just look at statistical performance of the model, you also want to look at the KPIs that are associated with this model. So let's say this 94% accuracy model caught smaller fraud transactions, a lot of them, but they missed some of the large transactions. So this is not necessarily a good thing, this is bad. But perhaps this model also reduced agent time. So because it has less false positives, there's less for the agents to manually review when they actually look at your backlog of transactions. So you have to weigh these KPIs with the statistical model performance and figure out what is most important for your business to track and optimize. So in this case, we might want to have one model that's predicting the likelihood of fraud, and then also figuring out another model that predicts the likelihood fraudulent amount in dollars. The next step from there is to start prototyping, and a lot of you, including myself, prototype in something like Jupyter Notebooks or Jupyter Lab, where you take your data, you go through a first pass at the data, prototype a model, figure out how the model performs statistically and based on the KPIs, and then check the results with business subject matter experts. So when you're checking results with business subject matter experts, a lot of them care about, well, if we actually deploy this model, can we get any value from it? So, you want to show not just the statistical performance, but the KPIs. So let's say going back to our fraud example, you might look at, what is the fraud dollar caught by decile. So if we have our model, we test it out on an out of time sample, we can look at, okay, if we had deployed this model, how much fraud dollars would we have caught? So does the model actually align with noticeable KPI improvements? So this is important to get subject matter experts looking at it, but also to get business buy-in for getting a model from the prototype to the next stage, which is deployment. So when we talk about model deployment, we're talking about taking that model and making its outputs available for decision making for your business. And typically that's done on new data. So when we take the model, there are different ways of deploying it. And you're familiar with different ways such as batch and real time, and a variety of ways to do it with less versus more complexity. So let's go through just a simple way of thinking about the less complex to the more complex. So let's say where we need little to no infrastructure, let's take a marketing example where you're just targeting customers with an offer. So that's pretty easy. You could just generate a CSV file from your model in Jupyter Notebook and give that to a marketing department, and then they can email those customers with that list. That's prone to a lot of potential human error, but it's really easy to get off the ground. It's really easy to see results quickly. Now, it can increase in complexity where we start looking at having more repeatable processes, having a more centralized storage. For example, we can still batch generate list of customers and their offers, but we can store that in a database, and we can access those results from a database in a batch format. We can also use databases for both batch and real time. So we might be able to store predictions from a batch process in a database, but then an application could access that database in real time and pull out those offers when customers land on the site. And then lastly, we can also just have a model being scored in real time. And as soon as customers land on the page, we can generate a prediction and get their offer. So there's a lot of complexity that goes building up complexity from the simple list to actually deploying something in real time. So let's actually talk about the next phase, which is building and deploying that first pipeline. So what the pipeline looks like will be determined by business needs. So those business needs are, where is that model deployed? So are you deploying on a website that you own? Is it something that is in a database that internally other departments need to access? Do you need to do this in batch? Can you get away with batch, or do you need to do it in real time? Figuring out the infrastructure that's needed and the teams that are involved. And often, and you've probably seen some of the talks today, there's a lot of teams like DevOps, data scientists, machine learning engineers, data engineers. They all work together to bring these kinds of projects to life. So figuring out at the very start who needs to be involved is critical on determining what the pipeline will look like. So let's take a simple batch example. As I mentioned before, we have an application that's generating data. We store that historical data. In batch, we generate a model. And from that model, we can generate predictions, a list, and then we can fire off that list off to a marketing department that can then send emails to customers with a targeted offer. So this is mostly involving maybe a small data science team, maybe one person, and then a marketing department that can go ahead and take those offers and send them out. Again, when we're going with the database and having something centralized that other parts of the organization can access, for example, again, a data science team would pull down the data from an application, generate a model, take new data and generate predictions that get stored in a database. And usually like an engineering or BI team would manage a centralized database where you have information about your customers as well as predictions from different models. A department like marketing could access that database to get what they need to send out their customized offer. And an IT department or DevOps department would maintain the connection between that database to the application if, for example, you wanted to use it to access predictions in real time. So even though the predictions are not generated in real time, they can be accessed in real time from this kind of a database. The other important part in this kind of a workflow is that you can create a feedback loop where you can monitor model performance. So you can get the predictions that you've already stored plus the actual outcome. So if your application is logging, well, customer A got offer X, and then they either bought the product or didn't buy the product within a certain amount of time, you can use that data in a feedback loop to further assess how your model is doing. And we'll talk a little bit more about the feedback loop a bit later. And now another example is when we go from batch to real time. So we have, again, a data science team that takes the model, creates the model, and generates some sort of artifact, and it can hand off that artifact to another team like engineering or DevOps. And that team maintains a different part of the organization where they can take the model, generate the predictions that become available to an application, take the data from that application, store it, and then again, update the model with a feedback loop. So again, this is increasing in complexity with different teams that are involved here. So here's some examples on different MLOps tools that can be used or for real-time scoring. So we have things like mLeap that can be used for both scikit-learn and Spark, for example. There are many tools, and I'll talk more about them later. I'll give you some links that you can look at. Ways to create real-time scoring include PMML. You can create an app with Flask. You can use Docker. So there's a variety of tools, and I won't be able to tell you which tool to use necessarily, but just keep in mind, depending on what your your infrastructure looks like and what your IT environment looks like and the architecture that you have, you'll have to figure out which of these tools fit your environment and what can you use. And I see a question, MML. So PMML is predictive model markup language, and it is a way to represent models in a language that's agnostic of where you deploy that model. And I'll talk a little bit about that in a second. Going back here into presentation mode. Hopefully it'll work now. Okay, perfect. So some of the things they need to think about aside from the tooling is, again, business needs. So do you need to make a decision in real time? You need to work with IT on figuring out what architecture do you currently have? What is your infrastructure? Do you need to buy anything new? Do you need to set something up? What is the cost of that? What is your budget? And figuring out what engineering involvement you might need and how much work they're willing to put in and how much they expect you and your team to be able to put in. And how do you have that seamless handshake between the model that a data science team creates and the outcome that the business sees at the end of the day? So let's go through an example. This comes from my time at Points, where we launched a system to basically rank hotels for a hotel search. So Points has a product called Points Hound, and if you go on that website, based on the information you put down in the search, as well as the hotel inventory that's available, we want to rank those hotels with the most likely to be booked hotel at the very top, because we know people don't like to scroll that much when making a decision. So we want the best possible hotel for each person to show up. So I'll talk about what we actually did for that system. So this is a homegrown system. This project went from about August of 2017 until November of 2018, from inception to showing ROI to the business. So this was in a time where a lot of the MLOps tools that you've seen today and some of the tutorials and other talks weren't available yet. Or if they were available, I wasn't that familiar with them. So in this example, what I did is, I've said before, I started with prototyping. Used Jupyter notebooks for this, scikit-learn for the actual models, and we also use Docker to maintain a data science environment that was reproducible regardless of who was running the code. So prototyping and subject matter approval was the first step to show that we think we can do better than what we're currently doing, and we think we can do better compared to some of the business rules that some of the subject matter experts came up with. Once we're happy with the model and its potential, we actually translated all the Jupyter notebooks into just Python code, and then we used GitLab to commit that and the data, and we used the GitLab pipeline with the CI/CD tools to manage that pipeline. So what we would do is, when we had new data coming in, we would hit a build, and then the build would go through, pick up the data, build a new model, and create model artifacts. One of the things I want to point out here is that anytime there are changes made to code, we built in approvals on those merges. So there was always someone else that would look at the changes in the model and the artifacts that the model generated, and then approve that. Some of the artifacts that the model generated included different metrics that we wanted to look at, charts, as well as the code that would go on to be put in production. So the code that we actually generated, one of the artifacts was the PMML code. The reason we went with PMML code is because I was building the models in Python, but the deployment area, the actual product itself for Point Sound, was built in Ruby. So we wanted to have something that was agnostic to where it was actually being deployed. So this is what we chose at the time. And we had something called a Ruby gem that was able to score the model in real time. We kept track of the models themselves based on the commits within GitLab. And what we did is we tagged releases. So the release of the model would coincide with software releases for that product. So we use Jira to track model releases and software releases and link the two together, as well as provide links to the artifacts directly inside GitLab. Once we actually had a model ready that was associated with a specific software release, that went into staging. So we had some testing just to figure out, like, is this the right model that we have in the staging area? We use a simple model, decision trees, to be able to track test cases. So if we put in a certain search parameters, we wanted to check what the search results came back as. And we also tracked the probabilities that the model generated as well as the input data. So we could easily do spot checking to see if the results looked reasonable. Once we saw that the model was good and it was the right model, it was generating predictions as we expected, we would move the model into production, but the model was not available, was not turned on by default. So basically we had a pool of models that would be in production and ready. Once a model was ready, we had an A/B testing interface that we built to be able to look in that pool of models, and with the model IDs that we generated, select the models that we would want to A/B test. So we also, from scratch, built an A/B testing framework where we could either do traditional A/B testing or we could do multi-armed bandit testing. So we would have 2 or more models available at a time, and we would load that into our A/B testing module. Once we had A/B testing parameters set up and we chose the models that we wanted to have in production, we would launch that with a particular, we could schedule it, launch it whenever we wanted to, ideally not at the end of the day and not on a Friday, so that we could keep an eye on it for a certain amount of time and have post-release checking to make sure that the model was behaving as we thought it was behaving. When we're checking post-release, we again had different dashboards that we built. And some of the most important things we tracked are the actual KPIs that affected the business, which is, how much conversion are we getting on hotels being served up from each of the models we have up in production? What is the average nightly rate that we're selling the hotels on? So the transaction size, essentially. And then we also had, and these were near real-time reports. And then we also had batch reports that we would run where we would start doing some statistical testing. So we would want to see, okay, if we have 10% conversion on model A and 8% conversion on model B, are they statistically different? And we would want to check that on a daily basis to see how the models are performing. And at the very beginning of when we started launching this, we also tested against subject matter expert rules. So we wanted to make sure that the model wasn't doing something that just didn't make sense from the business perspective. So this is a homegrown version of getting your model into production, and it does require a lot of custom built pieces. But as I've said before, there are more tools available today that can take over some of these pieces, and you don't have to build them from scratch yourself. So let's talk about the next phase, which is, how do you deal with engineering new features? How do you launch and iterate? And how do you add these new features to the pipeline? So again, this was talked about, if you saw Kenny's talk earlier, this is a very popular paper that talks about technical debt for machine learning. And machine learning is such a small part of the entire process. And I just want to touch upon a little bit on the feature portion, feature extraction and adding new features, a little bit about data verification, some process management tools, and monitoring, which I've talked about a little bit. But some of the considerations for data is whatever you use to build the model has to obviously be available during model scoring. And for a lot of tools, and at the time, it was difficult to get the pre-processing that we did in our prototyping stage be available within our production environment. So we had to recode that in Ruby and actually figure out exactly what calculations did I do at the time of model training so that we could replicate for model scoring. Something else to keep in mind is that even if you're doing things in real time for real-time scoring, you can still calculate other features that are very expensive to calculate in real time. You can do that in batch and just make them available in real time. So in some cases, with projects that I worked on, we had actually data that would come in on customers on a monthly basis. So we would want to, in real time, based on their profile, give them an offer. And some of the features were actually calculated offline and only once a month, but we would make them available in real time. So a lot of different ways can be, a lot of different ways can actually get the data where you need it to get it, even if you can't actually do it in real time. And you also just need to think about a process for creating new features. So an example I have is where we had one feature that we're calculating and had been approved by a subject matter expert that later we realized perhaps it wasn't the best definition for that feature. And we had a change that was suggested. So an engineer wanted to go in and just keep the feature name as is, but change the calculation. And I said, let's not do that because that's going to change how my models are behaving and it's just going to change all the past data. So you just need to be able to track, what is the process for creating new features? How do you communicate those new features across different teams? How do you use them? And how do you make them available for modeling and for scoring? Some process around deployment. Again, if you're working with multiple teams, figure out at the very beginning, how do you do handoffs between teams? What are sign-offs? Who's in charge of what? If a certain part of the pipeline breaks, who is responsible for fixing it? And again, tracking the data changes that may be coming either from the application, maybe coming from requests from subject matter experts or business owners, and having some sort of tool like Jira perhaps to keep track of who's doing what and anything like pre-deployment testing, post-deployment testing, and making sure that those kinds of tasks are assigned. Some thoughts around monitoring and reporting. So again, you can build your own dashboards to track these KPIs. And there are different ways of doing it. You can either build your own custom from scratch dashboards. You can do it in Python with any visualization package, use something like Tableau. It doesn't matter as long as you have a way to capture the model outcomes as well as the model predictions and link those up to the KPIs. And again, for the fraud example, you want to monitor if you actually labeled something as fraudulent, was it fraudulent? And if you labeled something as not fraudulent, can you get that label of whether it was fraudulent back into a single dashboard and look at how your model is performing? And then again, you might want to monitor how much fraud dollars were caught. And last but not least, A/B testing. So you've probably heard some of the other speakers talk about canary deployment. In this case, we built our own from scratch A/B testing platform where, again, we could pick 2 or more models and the amount of traffic that would go to each model. So that's more of a fixed way of starting from the outset with a specific traffic split and changing it based on statistical testing if a specific model did better than the other. Or you can use methods like multi-arm bandits where you can get more of the traffic started to slowly trickle to the model that's performing better than the other models. So there's different ways of approaching testing. but it is crucial to be able to test your KPIs and whether or not they're significantly different between the different models you have in production. And again, the last piece, the closing the feedback loop. So this is often overlooked. People get very excited about launching a model in production, generating predictions, and getting outcomes. And sometimes just the link between the predictions, the outcomes, and the business metrics is hard to put together. So if there are different databases where these get stored, or if the model predictions are going into, after they're being used in an application, they're actually not being stored. That's a big problem. So this is just a reminder that you want to be able to capture the model outcomes as well as the model predictions and the KPIs in one place to best assess how those models are performing. So some of the closing thoughts, I know we're coming up to time. So building correct infrastructure for model deployment and iteration can take a long time, especially if you're building it from scratch, like we did here. We started out in August of 2017, and we showed ROI in November of 2018. So it took a lot of iterations. There were many bugs. We've had models explode in production. So that is not great, but again, monitoring can help with that. And you'll definitely need not just data scientists, but data engineers, software engineers, DevOps and IT all to come together to bring something like this to fruition, especially in a large enterprise where there are many teams that touch different parts. Quite a few of you have asked for some resources on open source MLOps tools. These are the ones I've been spending more time with recently. So MLflow, MLeap, MLrun, and Kubeflow. And they have been a few talks I've noticed and also attended on these particular tools. So I've put the links in here, and the slides will also be shared. So you'll be able to go through these, or you can just search them online. Or go to any of the other talks talking about these. And that's what I had to cover for today. So let's go through some questions. Thank you everyone for sticking around. So let's start from the bottom. What are your thoughts on MLrun? So I've seen a few examples with MLrun. I really like the concepts of tracking different model runs and looking at the performance of the models. I did see some nice tools for example, describing data in one of the talks earlier. This is really useful, and this is one of the things I had help from software engineers. And what they did is I would write some Python code that's, I wouldn't really call production ready at this, like at the beginning, and a software engineer would help me refactor this code and provide utilities. So it's really nice to have these kinds of utilities that are reusable by other team members or in other parts of a pipeline, which is really nice. I don't know much more on MLrun, so I'm looking forward to spending some more time playing around with it. Another question is, have you used Kubeflow? And if yes, what are your thoughts? Unfortunately, I have not used Kubeflow. Again, it's on my list of something to try out. Let's see what else. Another question is, were the KPIs tested on a preset never changing data, or was the test data retrieved from recent history? Which one would you recommend? So we went through a few changes when we're thinking about KPIs. So at the very beginning of the project, we settled on some KPIs as being the most important and KPIs. And as we actually went through the project, we realized that perhaps we should be tracking other things. So we tracked as much data as we could to figure out, what are the best KPIs that most accurately reflect how the business is doing. So the KPIs, once they were decided upon and how we would calculate the KPIs and what these KPIs are telling us, we would monitor it constantly on new data, but we would look at all of the data so far. And what I mean so far is once we had a model in production, from the outset, we would start at we would start fresh, let's say. So at the very beginning, the model had no performance before any any of the searches started. But once people started transacting against the model, we would start tracking, what is our, for example, conversion rate, what's our average nightly basket size. So we track that fresh for that model. And the reason we did it is we didn't want older models to be influencing new models. So if we had a new model in production, we wanted to see how it was doing, but we would track throughout the model lifetime what the KPI was. And then once the KPIs, there's enough data to give us a good sense of how the KPIs performed against two different models, we would do statistical testing and see if they were significantly different from each other. And then we would do a champion challenger type of framework. So the model that won remained in production, and the model that lost would be replaced by a new model that was built on the most up-to-date data that we had available, and that would become the challenger in production. Another question we have here, on your A/B test, how do you make sure that you have similar sets for A and B, and do you switch them back and forth? So for the regular A/B testing, we basically had randomly split traffic between A and B. So let's say if we had two models in production, A and B, and then we just did 50% of the traffic going to A and 50% of the traffic going to B randomly. So we didn't switch them back and forth. We set them out from the beginning, and then we made sure to keep track of the cookies of each user coming in, so that if they saw A the first time they logged in within that model's lifetime, whenever they logged in, unless they cleared their cache, they would always see A. The other way that we did it is with the multi-arm bandit, where from the outset we determined how much of the traffic we wanted to randomly split between the different models. And we used the greedy epsilon algorithm for that. And then the rest of the traffic would go to the best performing model. But we set that at the outset. It was hard coded. And we did have plans to make that changeable by the user that's starting the test, but it wasn't the case when I left. There's another question here. Does the model get tested by the builder? So it depends on which part of the process and what kind of testing. So when I built the model, I tested the model in terms of how it performed statistically, and at the prototyping stage, we also looked at KPIs and how well it did. And basically, once the model was in that staging environment, there were some automated tests to figure out if it was the correct model that we had in production, but also the builder, which is being myself, I would check the model, I would check the tests, the sample tests and traffic that we sent through, and we'd also had a subject matter expert look at the search results, just like briefly look it over to make sure that the model results were not wonky, so to speak. Another question here. For A/B testing, do you also use control group to measure incrementality? So actually, when we started A/B testing, we went through a variety of phases. So we started out with our platform as is. We were getting hotel ordering from the Expedia API. It was based on something called hotel popularity, and it was only something we were able to update once a month. So that was our baseline, and we did an A/B test on the baseline versus rules that our subject matter expert came up with. So we said, okay, are the rules better than the baseline? And the rules were better than the baseline. We did significance testing, and we said, yes, these are much better. We're getting better results in conversion and basket size. And then basically we did that in a champion challenger fashion. So we dropped the baseline and then we had the first model go up against business rules. And the first model actually wasn't better than business rules. We knew we wanted to have machine learning in place just because when we were able to get more data and more features, subject matter expert rules wouldn't be enough. So we kept testing against these business rules until the models did better. Once the models did better, which happened a few months in when we captured more data, then we started having champion challenger framework with models. So we had a model that did better than the rules, and then a new model on new data was trained and was put in production against the model that beat the rules. And then we just kept doing this with on a regular basis with new data. Another question here is, do you version prototype Jupyter notebooks? If so, do you version with the same repo as production code? So typically what I like to do, whether using GitHub or GitLab, is have two separate folders, one for Jupyter notebooks and one for just Python code. So Jupyter notebooks do get version controlled. So any changes in that prototyping stage are tracked, and we can see who's doing it. We have branches for experiments. Depending on how large the project, we may or may not have approvals on merges for prototyping, but we do track that, and then we track Python code separately that will be used for production. It's usually in the same repo, but different folders. If there's any questions that I missed, there's one here. Can you name a few tools that you would use today to run the same model in production? Yep. So there's a lot of tools that are open source MLOps tools. So MLflow, MLleap, MLrun, and Kubeflow. Depending on what I needed to do, whether it was something internal or something for a particular customer, depending on their infrastructure, I would make the decisions based on that. So there's a lot out there. They don't all do everything, and you do have to do some work to bring all the pieces that I've talked about together, but you can definitely do it with some of these tools. You can deploy on Kubernetes. That's a very common one. You can create APIs using Docker images. There's many different tools that I would use today that weren't as popular when I started this project. There's another question about sending the links here. So yes, I can definitely add the links here in the chat. And again, the slides will become available as well as the recording. I'm just typing in the different links here. And there's another question. How big is your model in production versus prototype? So I'm not sure what you mean by big. So in the particular example that I went through, the model itself was a scikit-learn decision tree model. It was saved as a pickle, but we didn't actually use that pickle in production. So we used PMML code. PMML code is basically a little bit of text, so it's not a very large file. So if that's what you're asking, it's not a very large file in either case, the pickled model or the PMML code that was generated. I see here clarification parameters. So the decision tree model has a handful of parameters, hyperparameters that are set, and I did do a grid search for picking those parameters, but once I picked the best parameters, that's what went into the final PMML code that got deployed. Another question here is, how would you encourage your data science team to use traditional SDLC best practices? So what I've started doing with my team is to start one of the things is actually attending this conference. The other thing is basically starting to learn some of the open source tools, as well as some common things like using Docker. So with the help of developers, we set up a lunch and learn Docker session for everyone, uh, making sure that we get up to date on what's happening in the industry, and also just enforcing best practices. So starting GitHub repos, for example, for all of our projects, enforcing QA being done on code, having some oversight on what actually gets put into production, and also just planning for how we're actually going to put different models in production for different customers, and sort of planning based on their own infrastructure. So this is good practice to think about the system as a whole and how models can actually be used by an enterprise. Let's see, I think I covered all of the questions. I think that's it. So you can connect with me via email, or you can find me on LinkedIn. Send me an invite so I can just paste these in the chat as well. That is my work email, and here is my LinkedIn. So if you want to ask me more, or you just want to chat and connect, feel free. Thanks everyone for sticking around, and hope you have an excellent evening.